Going to dive into a few different types of questions that we want you to be able to answer when it comes to applying the formulas you've seen so far. But before we dive into those, we want to make sure and just recap what it is that we've seen so far. And these formulas you've seen, they all revolve around the number of sides, right? We've been seeing these relationships between the number of sides in a polygon and the sum of the interior angles, the sum of the exterior angles, the sum of the central angles, and sometimes finding out how much each one of these angles will be. Now, the formulas that work for absolutely every type of polygon are the ones that deal with the sum of the angles, right? If you want to know the total of all the degree measures of all the angles in a polygon added together, you just have to take the number of sides, take away 2 to find out how many triangles you could chop it up into, and then multiply that by 180 in order to get the total of all the interior angles. Now, if it happens that you're dealing with a regular polygon, that means all of the interior angles are the same as each other, then you can just take that total of all the interior angles and share them out between the n vertices, right? And that's how you end up with this other formula that you've seen, which is just the same formula divided by n, right? It's just this formula up here, which gives you the total, but then you take that total and you share it out between n sides. That's what dividing does, right? You divide up a pizza, you're sharing it out. So you get all the degrees that everybody's allowed and you share it out between the number of vertices. This is all the angles together. This is just one of them, and this formula only works if you're dealing with a regular polygon. Likewise, you can get the sum of the exterior angles for a polygon. Convex polygons, it works more clearly, but it also works with a little careful math for concave polygons. But whichever way you look at it, you will get that there's 360 degrees is the sum of the exterior angles of a polygon. Now again, if it so happens that the polygon you're looking at has all of its exterior angles the same, because it's a regular polygon, then you have another formula you can use which tells you the number of degrees in a single one of the exterior angles of a regular polygon. And that's just the same total, 360, shared out between the number of exterior angles you're dealing with, in this case, n. As it happens, the formulas for central angles are the same. Now, it makes sense that all the central angles, the middle of a polygon, if it's a regular polygon, they'll add up to 360 as well. And if you want to find out just one central angle, you share it out between however many central angles you need, because that's the same as the number of sides, and I'll give you one central angle of a regular polygon. Now, all these formulas that you've got here, they can be pretty straightforward to apply if your question is nice and simple, right? Like this one here, it just says, what is the measure of one interior angle of a regular octagon? So this is a kind of question where you just look at the formulas that you have and you say, well, it's asking me one interior angle of a regular octagon. Let me look, see which of these formulas make sense. Well, down here, it's one interior angle of a regular polygon. So let me use this formula here for this question. It's saying the measure of one interior angle of a regular octagon. Well, that means that I know that my n here is equal to 8, because n is just the number of sides, and I know that an octagon's got 8 sides. And if I know that n is 8, I can just take my formula for the measure of one interior angle and plug n as 8 into that formula, right? My formula was 180 times n minus 2, all divided by n, right? That's your formula for one interior angle of a regular polygon. Now, if n, like we see here, is 8, then I just have to go into my formula and change all those n's to 8s. And now I just have a pretty simple calculation to do, right? I've got my formula with the proper number plugged in. Let me put a little dividing line here so I can keep track of what I'm doing. And I just got to do the calculation. 8 minus 2 is 6. So let me write that in. 180 is now times 6, because I've calculated what 8 minus 2 is, something I learned a long time ago. And that's still all over 8, right? 180 times 6 over 8. So now, again, let me put a little line in there so we can keep track. So 180 times 6 over 8. I do 180 times 6 first, which gives me 1080. So now I've got 1080 over 8 is the calculation I need to do. And if I get out my calculator, I do 1080 divided by 8, I'll get that that equals 135. So my final answer is just 135. I don't forget my units here. They're not centimeters or centimeters squared, they're degrees. Okay, so I've got my final answer, 135 degrees. I've got little equal signs going along here to keep track of my work, which is easier with a pencil than it is on screen, I can tell you that much. But if I do everything right, I'll have that there's 135 degrees is one interior angle, right? So far, so good. I'm just taking my formula, I'm plugging in the number in the right place. In this case, n is 8, so I plug it in there, and I calculate my answer. And likewise, if I have a question that looks like this, what is the measure of one exterior angle of a regular dodecagon? I say, okay, well, you're getting pretty fancy there with your dodecagon, but I know what n is if I'm dealing with a dodecagon. That just means it's a 12-sided figure, right? I figured out that n is 12 here. So if I want to find the measure of one exterior angle, I just take the formula for one exterior angle in a regular shape, which is 360 over n, and I replace the n with 12, because I know in this case that I'm dealing with a dodecagon, and that's got 12 sides. Now I got to do the calculation here. This one's not going to take very long. I can get my calculator ready. I type in 360 divided by 12, and right away it'll give me the answer, which is 30, and degrees are my units here, right? And that's my answer right away. So I'm saying to myself, well, all these angle questions are pretty straightforward, right? Even something like this, we're talking about central angles. Suddenly that's, well, maybe something I'm less familiar with because it feels more like a circle question. But I can still do that. I use my formula. 360 over n is my formula for the measure of the central angle in a regular polygon, right? And if I'm dealing with a decagon, I have to say to myself, well, what is n in a decagon? The answer is that n is 10. Right? My decagon's got a 10-sided shape. So I got to go back to my formula. Instead of saying 360 over n, I'm going to say, well, let me replace that n with 10, and then I can do my calculation right away. 360 over 10, if I plug that into my calculator, I don't even need to think about a calculator for that, because you divide something by 10, that just means you have to take a 0 away from it. You'll end up with an answer here of exactly 36 degrees. And that's your answer for the measure of the central angle of a regular decagon. Again, just taking the formula and plugging it in. What I want you to be able to do, however, is to be able to handle things when they get a little more complicated, like this one here. Let's see why this is more complicated first. A regular polygon has an exterior angle that measures 4 degrees. How many sides does it have? All the other questions we've been doing so far, we've been figuring out what n is, then plugging it into the formula. But here we don't know what n is, right? It doesn't say, like that other example, decagon or dodecagon or octagon. It's asking me how many sides it has, and I don't know yet. So what I got to do here is I still have to figure out the proper formula that applies. It's a regular polygon, and I have the measure of an exterior angle. So if I go back, regular polygon, exterior angle, that's 360 over n. That's the formula that's going to be important, 360 over n. Except here, when I think of that formula, 360 over n, I can't just take the n that I have from the problem and plug it in, because I don't know how many sides it has yet. That's what I'm actually trying to find out here. So instead, what I've got to do is I've got to make an equation where I put the information that I have on one side of the equal sign and the formula for that same thing on the other side. Here the information that I have is that the exterior angle of this regular polygon is 4 degrees. So I've got 4 over here, and on the other side of the equal sign, I've got the formula that matches that piece of information. The piece of information is one exterior angle of this regular polygon. The formula here is for one exterior angle of a regular polygon. Now that I've set up this equation, I should be able to calculate what n is. Now, some of you guys would have different ways of solving this. Probably the best way would be to cross multiply here, do n times 4. If it makes it easier for you to understand the cross multiplication in your head, you can also put this in here, though mathematically you certainly don't need to do this. This is just 4 over 1 here, right? So 360 times 1 is equal to n times 4. 360 times 1, you don't need your calculator for that. 360 times 1 is just going to be 1, but we'll write it out for now. And on the other side of the equal sign, you've got just 4 times n, which algebra tells me I can just write as 4n. So 360 times 1 is just going to simplify to 360, and 4 times n is still just 4n, right? So if I want to get n alone, if I want to isolate it, all I have to do at this point, divide both sides by 4. Right? I'm going to do the same thing to both sides of the equation. Those are the rules for algebra. And if I do that, I end up getting that 90 is equal to n. Now, you saw I put 90 degrees there first. That was a reflex. But let's see if we can figure out the right units here, right? When we divided 360 by 4, we got 90. We divided 4n by 4, we got n. The answer is telling me n equals 90. That doesn't mean the degree is 90 degrees like I accidentally said a second ago. It means that I've actually got a polygon that's got 90 sides. The answer to my question here would actually be, if I gave a full answer, a proper one here, the polygon has 90 sides. Now, some of you guys might be trying to remember what you call a 90-sided figure. There's one video I had you watch where it said that it's a nonacontagon, but you do not need to remember that. The question is just asking how many sides does it have. The answer is 90 sides. All right, so we had to